So out of the 500 car owners investigated, 400 owned car A and 200 owned car B. 50 owned both car A and car B. Is this data correct? And next is to solve the inequality. Next is to solve the equation. Next is to find equation of alignment, specify the quadrants in which the points lie. And lastly, find LCM and GCD of the three numbers, 56, 84, 91. The first question is interesting. It is testing whether you understand the concept of cardinality of sets, especially the union of two sets. So let's check how to solve the question. So we are being told that out of 500 car owners investigated, 400 owned car A, so cardinality of A is given by 400, and 200 owned car B, so cardinality of B is 200. 50 owned both car A and cars B, so which means the cardinality of the union intersection of two sets A and B is 50. So out of the 500 car owners investigated, so we know that the cardinality of A union B is given by cardinality of A plus cardinality of B minus cardinality of A intersect B. So this will give us (400) plus 200 minus 50. So we should be 600 minus 50, which is given by 550. So let's call this one question 1. And the question clearly told us that out of the 500 car owners investigated, so mean that 500 people own these two types of cars. So that means cardinality of A union B is given by 500 from the question itself. But then clearly, we see the number 500 doesn't match with 550. So 500 is what is being claimed that is the cardinality of the union of the sets which were being considered. But then now with the information given, using the inclusion-exclusion principle, we see that the number should be 550. So since the two values do not agree, then we say that this data is actually incorrect. So hence, this data is incorrect. Next question, solve the inequality and represent the solution on the number line. So we have -5 less than 3x plus 1 less than or equals to 10. The easiest way to solve this, remove this constant here by subtracting on either side. So we have -5 minus 3 minus 1 less than 3x. When you subtract 1, then you don't have the constant, less than or equals to 10 minus 1. -5 minus 1 is -6. less than 3x less than or equals to 9. So to get x, you divide through by 3, so which implies minus 6 over 3 is less than 3x over 3 less than or equals to 9 over 3. So which means minus 2 is less than x less than or equals to 3. So that is the solution. On a number line, we'll write this. So we have at 2, at negative 2, then we have at 3, but this less than or equals to means that we shade this part. Shade this part at 3, but leave 2 at 2 open, then join these two circles, and on top of those circles, write the compound inequality. So that's how we solve that question. Or if you can't do it in one, solving the compound inequality in one step as we've done here, you can just separate. Or we have minus 5 less than 3x plus 1 less than or equals to 10. So you form two simple linear inequalities from this compound statement. So which will be given by so from this, you get one inequality. And then from we have this, get another one. So then minus 5 is less than 3x plus 1 is your one inequality, and 3x plus 1 less than or equals to 10 is your second inequality. So from 1, you will have minus 5 is less than 3x plus 1. So minus 5, take 1 to the other side, will be minus less than 3x. So minus 6 is less than 3x. So which means divide through by 6 minus 2 is less than x. And then from 2, we have 3x plus 1 less than or equals to 10. Collect like terms. So 3x less than or equals to 10 minus 1. 3x less than or equals to 9. So which means x less than or equals to 3. And once you have that answer, you pick this, join to this. So we'll have minus 2 less than x less than or equals to 3, just as in the first case. And then you draw the number line. Another possible question you can be asked on that is to find the integral values of the solution. So it's easy to define the integral values once you have the number line. So it means all the integers which are within the range of the solution set. And we clearly see that in this case, we have, so minus 2 is not part of the solution, so we start counting from minus 1, 0, 1, 2. 3 is also part of the solution. So this will be the integral values of the solution set. Then solve the equation 2 over x squared plus 1 equals to 3 over 2x squared minus 11. 2 over x squared plus 1 equals to 3 over 2x squared minus 11. So the easiest way is to cross multiply. So solution, cross multiply to get 2 into 2x squared minus 11 equals to 3 into x squared plus 1. So this will be 4x squared minus 22 equals to 3x squared plus 3. Collect like terms. So 4x squared minus 3x squared equals to 3 plus 22. So x squared equals to 25. So x equals to square root of 25. But remember, square root has plus or minus. So therefore, x equals to plus or minus 5. So you must have both the plus and negative sign to get full score. So find the quadrant in which points A minus 2, 5 and B 4 minus 7 lies, and hence find the equation of the line joining these 2 points. So when you draw x and y axis, this region is usually called first quadrant. This region is called second quadrant. This region is called third quadrant. This region is called fourth quadrant. And this point here is what we call the origin. So if you label this axis, for example, this is 1, this is 2, this is 3, -1, -2, -3, -4, 1, 2, 3, 4, -1, -2, -3, etc. So all points in the first quadrant, remember when plotting a point, you start with x value followed by y value. And x is usually what we call the abscissa. While the y value is called the ordinate. So for any point, you start with abscissa followed by the ordinate. So in this quadrant, first quadrant, every value from here to infinity will have a positive sign followed by positive sign. So x is positive, y is positive. This quadrant, x is negative, but y is positive. In this quadrant, x is negative and y is also negative. In this fourth quadrant, x is positive, but y is negative. So this is how you can actually identify the location of a point in terms of quadrants once you have the Cartesian plane. So the first point, A, is given by -2, 5. So -2, 5 the signs are minus, positive. And when you come to this sketch, we see that minus followed by positive is in the second quadrant. So therefore, A -2, 5 is in second quadrant. Point B is given by 4, -7. Now 4, -7 this is plus, minus. plus minus is fourth quadrant. So B 4 minus 7 is in the fourth quadrant. That's what you have. Now the last part is to find the equation of the line joining point A and B. So if this is A minus 2, 5, B 4 minus 7. So the first find M, which is change in Y over change in X. So 5 minus 7 over minus 2 minus 4 should be 5 plus 7 over minus 2 minus 4, which is 12 over minus 6, we get minus 2. And equation of a line through any point AB is y equals to m into x minus a plus b. And remember, b is any point on the line, so you can either use what you have at a or b. So if I pick a, I'll have minus 2, 5. Then m is minus 2. So the equation will be y equals to minus 2 into x minus 2 plus 5, which will be y equals to minus 2 x plus 2 plus 5, y equals to minus 2x minus 4 plus 5, which will give us y equals to minus 2x plus 1. Or you could as well pick the point at B, which is 4 minus 7. You get into the same minus 2, so it'll be y equals to minus 2 into x minus 4 plus minus 7. So it'll be y minus 2x minus is plus minus 7. So y equals to minus 2x, 8 minus 7 is positive 1. So whichever point you pick, you get the same answer. Lastly, find the LCM and GCD of 56, 84, and 91. So LCM means least common multiple, while GCD means greatest common divisor. So divisor is a number which can divide another number without a remainder. For example, we say 2 and 3 are divisors of 6, which means that 2 can divide 6 without a remainder, 3 can divide 6 without a remainder. While a multiple is a number which, when you divide by another number, you don't get a remainder. For example, we say 6 and 12 are multiples of 3, since both 6 and 12 can be divided by 3 without a remainder. Now, to get the LCM of, let's start with LCM. You write 56, you write 84, you write 91. So you start by the smallest prime number that can divide any of the 3 numbers. Not necessarily all of them, but any of the 3. when you're defining the LCM. So 2 divide 56, 28, this 42, but it doesn't divide 91, so you write 91. So that's the first step. Second step, get the least prime number that can divide any of these three numbers. So still 2, divide, say, 28 14 times. This is 21, doesn't divide 91. Still 2 divides 14 7, 21 doesn't divide, 91 doesn't divide. Next prime is 3, that divide 7, divide 21 by 7, doesn't divide 91. Next is 7, 1, 1, 13. Next is 13, 1, 1, 1. So for LCM, you do that up to the point the last line has ones. Then you multiply these numbers. So once you have reached 1, then you multiply these numbers here. So LCM is 2 by 2 by 2 by 3 by 7 by 13, which gives us 2184. GCD, so we have 56, 84, 91. Unlike for LCM, GCD you must find, you start with the least prime factor or prime divisor or prime number that divide all the numbers. All the numbers. So the smallest prime that can divide all these three numbers is 7, 56, 8, 84, 12, then 13. Then 8, 12, and 13 have no common prime number that divide all of them. So therefore, GCD is just 7. So that's how I solve those problems in that part. Thank you.